AI, please test my app with senior architect Gill. It will take me more than the hour that we have allocated for the session to talk about all the things that Gill has accomplished in his career, which spans 3 decades. So I'll just give you the highlights. Gill is a senior architect and evangelist at Apply Tools. He has over 30 years of experience with software development. He has co-founded Web College and worked on some of the largest projects at Wix. Gill is also a sought-after public speaker, and he frequently talks at notable international conferences about test automation and software development, conferences including Selenium Conf, Star West, Star Canada, just to name a few. Gill will also be a faculty member at Test Automation University, and starting next year, you will be able to take his course about visual validation for front-end developers with Storybook and Cypress. So without any further ado, I suggest we let Gill do the talking now. So Gill, take it away.
Thank you, Adi. I hope everybody can hear me. Not only cars, AI, please test my app. This is going to be a talk about the future of software testing and AI, a lot of AI. Okay, so this talk is a bit interesting because it's trying to build similarities between AI and driverless cars and AI in testing, and I'll talk about that in a second. So let's start with driverless cars. Driverless cars are here. I mean, we're seeing them in the news all the time. And you may not remember it, but it was 6 years ago that Google passed Nevada's self-driving car test and amazed the world with what, for me, was science fiction. It was incredible. I could not believe my eyes when I saw that. And once that firing shot happened, it was war. Everybody, whether they're car manufacturers like Ford, Mercedes, Volvo, General Motors, or whether it's software developers, Google, Apple, Intel, Uber, a lot of them declared war on one another. They all wanted to get into this really, really fabulous thing called driverless cars. And the big question is why? Why did they want to do that? And the first answer to that is because driving is boring. It really is. You want to get I mean, there are people that enjoy driving, but definitely not in all those traffic jams. And, you know, riding 1 hour from one place to another in a traffic jam is incredibly boring. And boring is fine, but the worst thing is that it's dangerous. A lot of people get killed every year, and because they're careless. They're looking at their phones. They're thinking about work or thinking about home, and bad things happen, and that costs everybody, including a lot of money. Insurance companies, the state, et cetera, a lot of money. A lot of money is being poured into safety, and this dangerous thing and the fact that it's boring means that people will probably want driverless cars as quickly as possible. So everybody's frantic in getting to this really new market. And the whole boring and dangerous thing, and once we have driverless cars, instead of thinking of how to get from one place to another and the mechanics of driving, we can start concentrating on what we want to do when we get there. We want to work, we want to get home and be with our kids, whatever. Instead of thinking about the dreary, boring steps of getting to a place with the car, we can start thinking about what we do when we get there. And that is exactly like testing. Software testing and automated testing, we really want to test A and B and C in our software. We really want to do all that. But the cost of writing all those tests and making sure that they're flaky and all they're not flaky and all that, the mechanics of it is unfortunately somewhat boring. It's incredibly important to reach that automatic regression testing thing. We can't live without it a lot of times, but getting there is a bit problematic. So, I'll skip when we were talking, we have an algorithm team at Applet Tools that deals with the AI algorithms that Applet Tools has. And I was talking to the team leader. We were sitting one next to another, and we were like, "Hey, driverless cars are very similar to software testing. Maybe we can find similarities and see how driverless cars are progressing and advancing in their states and in their levels, and find similar levels in software testing." And we started brainstorming this thing and thinking about the similarities, and we got quite a lot of similarities there. And this talk is basically showing what those similarities are, learning about AI techniques during that understanding, and seeing where software testing with AI is progressing to. So let's start with talking about autonomous driving and understanding that. So as I said, driverless cars are here. Tesla, this was like a year ago, this number, a year or two ago, is now at 222 million cumulative miles driving the Tesla autopilot. And Google, Waymo is the company that Google founded for driverless cars, is at 3 million, and that was May 2017. I'm guessing now they're at 12 million or whatever, because this is exponential. So we have 222 million for Tesla and like 10 million or so for Google. So is Google winning the war? Is Tesla winning? Maybe others. It seems that Tesla is doing great, but that's not exactly true, because Google is way more advanced. The level of autonomy of its cars is way more advanced than the level of autonomy of Tesla's autopilot, Tesla's cars. And to understand those levels and to standardize our understanding of those levels, the SAE, the Society of Automotive Engineers, and the National Highway Traffic Safety Administration defined 5 levels of autonomous driving. And let's go over them, because as we will see, there are similarities with what we will define as the 5 levels of autonomous testing. So let's go. Let's start. First of all, we have level 0. And congratulations, you're the proud owner of a level 0 car. Level 0 means no automation whatsoever, so everybody has that. Let's progress to level 1, driving assistance. Driving assistance is what is called cruise control or adaptive cruise control. It's where you can drive and you can press the gas, and it doesn't matter if there's a car in front of you. If the car senses that there's a car in front of you, it will brake no matter what. It will not make you bang into the car in the front. So that's driving assistance. And to understand driving assistance, we need to understand what happened to make driving assistance available in today's cars. And it's all about vision. It really is all about vision. For a car to have driving assistance, level 1, it needs to see the road. It needs to see other cars. So it's all about vision. And the vision here is usually what is called LiDAR, light detection and ranging. It's a technology. You've seen it in autonomous cars. It's this, maybe you've seen it. It's those little revolving radars that look like radars that are on the top of the car. So those little revolving things are revolving and sending out pulses of light everywhere. And those pulses of light are going out in a straight line and coming back because they're being reflected from other stuff, cars, trees, the road, etc. And if we time the distance, we can figure out what the distance is at that specific point. So we can get a 3D map, not even a 2D map, a 3D map of exactly what those objects are. Another way of doing that, I think Tesla is doing that, I'm not sure, is stereoscopic cameras. If we have 2 cameras and they're each a little distance from another, and we take constant videos from both, the parallax, the difference in how they view the road, can enable a computer to understand what is going on in front, just like our eyes. Our eyes, what we see are 2-dimensional images, but the fact that we have 2 eyes enables our brain to sense the depth in what we see. Another technology is radar, the regular radar, although I haven't seen it a lot, but I don't know, Wikipedia says there is. And it's all about vision, obviously, the technology about vision, but it's also about the algorithms to understand what is being seen. If we can get a 3D depth map of what is going on, it doesn't help if we don't understand that that is a car, or that is the road, and that is a tree, and that is a person. Let's continue on. Partial automation. Partial automation is where Tesla is at. It's the ability to drive on a highway, stop and brake if there's a car in front of you, and switch lanes. Switch lanes means that we're talking about the AI handling the steering wheel. So I can take my hands off the steering wheel and let the AI drive the car in highways currently. Even though other people I've heard used it, and not in highways, but Tesla says definitely do not. So how does that work? And to understand that, we need to understand that, I mean, in terms of how an autonomous car sees, we're done. LiDAR is the state of the art. People are improving it, obviously, but it's basically the end game. But the algorithms that I need to cruise between lanes, etc., are much, much more interesting than what I need to just brake a car if there's something in the front. And it's all about AI algorithms. If the algorithms previously were not AI algorithms, these are definitely AI algorithms that use machine learning and neural networks and deep learning, and we'll talk about that. And it's all about the algorithms. And to understand AI in autonomous cars, we need to understand the algorithms. And it's really, really fun. I'm not an AI guy. I sit next to the AI guy. And when we were brainstorming, I started, asking questions. How does this work? How does machine learning work? What's deep learning, et cetera, et cetera. And I like to transfer that knowledge to you because I think it's interesting and very relevant to the whole thing. So it's all about neural networks. Both machine learning and deep learning is all about neural networks. And this is a neural network. And how the neural network works, from the left, the X1, X2, X3, and 4, come inputs. These inputs are just numbers, okay? And they pass through the nodes and go through the pipes. That's the lines between the circles. The circles are the nodes, and the pipes are the lines between them, until they exit on the right in Y1, Y2, Y3, which are numbers. So a neural network is basically a set of nodes connected by pipes, numbers coming in and numbers going out. That is all that a neural network is. Nothing more, nothing less. But let's understand how that translates to a computer seeing something and acting upon it. And let's start with a simple example. As usually, we're in the internet area. So we have pictures of cats and dogs. And we want to understand which of those pictures are cats, which are dogs, and which are not either. And how does this work using neural networks? And the answer is, if you take an image, a picture of a cat, a picture of a dog, or whatever, that image is lots and lots of numbers. Each pixel is, well, basically a number. It's 3 numbers, but that's fine. If I take all those pixels and push them into a neural network as the input, it's a bit more complicated than that, but it's not much more complicated than that. If I take all those inputs, push them into the neural network, what comes out of that neural network is the probability that it's a dog or a cat. So in comes an input, an image, out comes a number, which is the probability that it is a dog or a cat. So this is how we use, and there are more ways to use it, but basically taking an image, putting it into the neural network, taking it out, and now we have a result. But how does it work? How does the neural network know that it's a cat or a dog? It's actually pretty simple. And to understand it, we need to understand what is each node here. Those nodes are called, by the way, neurons, because the idea around neural networks is to simulate how the brain works. At least that's the marketing. And a neuron, both in the brain and in a neural network, takes inputs, numbers. In a neuron, those numbers are basically electrical signals, and The output is a number in a neural network, and in a neuron in our brain, it's also an electrical signal. And the value of the electrical signal, the output, the amount of the electrical signal, that's the number. So in a neural network, in comes the numbers. Each number, x1, x2, x3, is multiplied by a weight. Each of these numbers has a weight attached to it, w1, w2, w3, which is determined by that neuron. And what we do is we sum them up. x1 times w1 plus x2 times w2 plus x3 times w3. We normalize it a bit and out pops a number. Remember, we're in a neural network, so that number is the input to another neuron, etc., until we reach the final numbers. So that is it. It's summing up using weights. That is all there is to a neuron, and that is all there is to a neural network. But the big question, which makes AI so complicated to build, is who decides the weights? Who decides W1, W2, W3? X1, X2, X3 is my input. It's the pixels of the cat or the dog. But W1, W2, W3 determine how the neural network works. Who decides the weights? And the answer is training and backpropagation. So how does it work? And this is the training part. What I do is I feed the image of a dog. Okay, I feed the image of a dog, and out comes a number, which is the probability. Let's say I feed in an image of a dog, and out comes 95. I say, oh, well, let's simplify it. Out comes, yes, it's a dog. I say, great. And now I feed it, a cat, and it says it's a dog. Oh, well, the neural network got it wrong. The weights in the neural network got it wrong. So what I do is in this case of this image, I backpropagate and fix the weight in a very complex algorithm, which I couldn't make heads or tails of when the AI guy explained it to me. But it doesn't really matter. Every good image, which it calculates correctly, the weights stay the same. Every bad result, the backpropagation works and fixes the weights according to a certain algorithm. And then I feed in hundreds and I feed in thousands and maybe tens of thousands of pictures of dogs and cats and birds and whatever. Each good image, the weights stay the same. Each bad image, backpropagate and fix the weights. Until after a while, after lots of training, most of the results will be good results, or almost all the results will be good results. And I can say, good, the network is ready, and I can take that network. I've stopped training it, and now I can use it in production, in the car, if you want. And this is why the mileage numbers everybody's flouting actually, are very important, because neural networks need lots of data. And to get that data, we need to drive a lot. And I was talking about machine learning and neural networks. Let's digress a bit and talk about what is machine and deep learning. Actually, deep learning is a subset of machine learning. Machine learning is neural networks and other sorts of algorithms that do AI. Deep learning is, let's take a neural network and have lots and lots of neurons in it, and lots of layers of neurons in it. And the ability to do that is actually ability we got only in the 21st century. Once computers became fast enough to do that, once we had GPUs that can do all those calculations in a crazy fast amount of time, we could do that. Before we had all those really, really fast CPUs and GPUs, we could only do a certain amount of neurons. Now we can do a lot of layers, lots of neurons, and deep learning is where the whole thing is at. And deep learning is how we can do vision, because before that, vision wasn't really possible with a few neurons. So that's machine versus deep learning. But how does this work in cars? Okay, dogs, cats, that's fine. How does this work in cars? And the answer is there's no one answer. There are a lot of algorithms inside those autonomous cars that deal with lots of stuff. For example, in comes the image of what's going on outside. Out comes the speed limit, 50, or there's a stop sign here, or there's a traffic signal here, a red traffic signal, so you should stop. Lots and lots of algorithms that figure out what is going on. In comes the pixel numbers, out comes a result like speed limit. So this is one way of working. Another is maybe the main way. Think of it. In comes the picture of the road, and out comes the angle of the steering wheel. So that's also, and crazy enough, that's how it works. It's probably more complicated, but in general, that is how it works. In comes the pixels of the image of the road, and out comes the steering wheel angle. So this is how deep learning and machine learning and neural networks work in cars. So this is level 2. Level 3 is much more autonomy. Humans do not need to monitor the car, and if a car will figure out that it can deal with the situation, it beeps or something and lets the driver take over. Level 4, and all these use machine learning and deep learning, just better and better and better at it. Level 4 is high automation. No steering wheel needed, because and not in any case will the AI accede to the driver and notify it that there's a problem. But why is it not level 5, which is the best? Level 4 is, it works great when it works, but there are situations like fog and snowstorms where it doesn't. Google is there. Google is at level 4 and progressing nicely towards level 5. But I think they just started a taxi service somewhere in Phoenix. That's a taxi. Phoenix is nice, always sunny, no rain, no, definitely not snow. So that is where they started, because they are at level 4. Level 5 is full automation. It's the holy grail. Nobody has reached it yet. It means, just go to sleep. Rain, snow, fog, you'll get there. Don't worry. We're not there yet, but it's fun to dream. Okay, now that we understood the levels of autonomous cars and the algorithms and the technology behind it, let's talk about autonomous testing. First of all, level 0, no autonomy. No autonomy doesn't mean no automation. It means there is automation, but nobody helps you write those tests or validate or whatever. So congratulations, you're probably the owner of a no autonomy test suite. Driving assistance, that's level 1. So what is the parallels with level 1 driving? And the answer is, it's all about vision. If the AI can see what's going on, whether in terms of the data on the page or whether in terms of the vision of the page, this can probably help us do stuff. And what can it do? How can visuals or the understanding of data help? And the answer is, if we look at all our tests, all our automated regression tests, they're basically action, validation, action. Click here, enter here, then validate that this field is that value, that field is that value. If the AI can see the page, can it assist in validation? And the answer is yes. I mean, if I can take a screenshot of the page and compare it with another screenshot that I previously had in which a human said it is okay, then I can immediately, without dealing with all those pesky selectors, I can immediately say whether that page is okay or not. And comparing two pages is actually not that simple. You can't compare pixel by pixel. You need AI algorithms to ignore the little differences that are ignored by a human, and yet pick the differences that are the real differences. So AI is already assisting us in that level. We need better understanding, but it's not enough. We need a better understanding of what we see. Just comparing two pages that should be mostly identical is great for level 1, but let's see what level 2 is. And level 2 is all about AI algorithms. Once we have the capabilities of machine learning and neural networks, etc., we can go one level higher. And for example, we can compare two pages that are different, that have the same layout, but are different in terms of the data inside them, the pictures, the text, etc. Think of two tables where you're looking at the two tables and you can suddenly look at the data and compare them, and the AI, based on previous results and the machine learning that it did, can say that those values are correct and incorrect based on previous values. So not only do you not need to validate those data terms yourself, AI will do it for you, and it will do it for all the data on the page. Great. Level 3 goes one way because we needed to tell the AI in level 2, human intervention is still needed. Level 3 means no human intervention. It means that the AI will be able to spot errors even if it had never seen the page previously. So errors in design, errors in data, all kinds of stuff can be read by the AI and dealt with. Nobody's reached level 3 yet. Some companies are working towards that. I think Applitools is level 2, progressing nicely towards level 3. Okay, and we talked about how, looking at hundreds of test results, seeing how things change over time, and if there's an anomaly, you need to send it over to a human to check. But a human still drives the test. You still write the test that does click, 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 validate, click, 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 validate, except that most of the validation can now be done by an AI. Level 4 is really cool. Level 4 means the AI is driving the test. And how can an AI drive the test? And the answer is, if I have the system running, whether by humans, the system, the product running in production, say, and let the AI look at that information of what humans are doing in the test, then it can start to understand that application, just like this AI is learning how to run, to win at Pong, at this game of Pong. It doesn't really understand the game or the rules of the game, but it observed what happened previously and can now play the game on its own. That is called reinforcement learning. So if our AI can look at what humans are doing in production, in the product, and start learning what it's doing, then it can start testing by itself, not only validating the results, but also writing the tests themselves. That's level 4. That's really, really, really interesting, but we're definitely not there yet. Level 5 for me is AI. Sorry, not AI, science fiction. Total science fiction. I don't know when we'll get there, if we will ever get there. And level 5 is like I'm flying on the wings of fantasy here. The idea is that the AI will be able to talk to the product manager, understand the application, and drive the test itself without observing anybody. It's basically getting the specifications and writing the tests. Obviously, nobody ever understood a product manager, let alone testers, let alone an AI. So AIs will need to be much smarter than human beings to reach this level. So yeah, I actually don't think this will ever happen, or maybe it will. Who knows? I added another level, level 6, Skynet level. No more humans. The robots have killed all the humans. And there's no need to test anymore. But as I was thinking of Skynet, I was thinking, but those robots build other robots, and probably more advanced robots. Who tests the robots? Probably little AI QAs, running and testing all those robots, doing manual testing and exploratory testing and automated regression testing, and having all those conferences, etc. It's probably going to be funny to watch. But okay, so we've seen the 6 levels. We've seen how AI will help. We've seen that we're roughly around level 1, level 2, slowly progressing towards level 3. Are we there yet? Is AI, that's a big question everybody's asking me at conferences. Are we there yet? Is AI going to replace me? And should I be looking for another job because testers will be obsolete in like 5 years? Let me put your mind at ease. AI never, not in autonomous cars, not in autonomous testing, not in autonomous anything. AI doesn't really understand what's going on. And to prove that, this is the picture of a banana on top. And if I do the right neural network, machine learning, deep learning thing, it will know that it's a banana. It will understand. It will know that it's a banana. It will never understand that. It's just a neural network. In comes the numbers, out comes whether it's a banana or not. It's just weights and multiplications and sums. That is all it is. To prove that, a group of computer scientists took a small sticker on and put it next to the banana, and they asked the computer what it is, and well, we can see immediately it's a banana next to a sticker. The sticker means nothing. We know that because we really understand what is going on there. We don't, we're not just weights and sums and neurons, etc. We have higher level stuff going on there. So, but an AI is easily fooled. And there's a big question on whether we can fool autonomous cars, and autonomous cars needs to safeguard against this kind of fooling. But they're easily fooled, and in this case, the AI will think it's a toaster, not a banana. It's that easily fooled. So no, AIs don't really understand. AIs are just very complex and interesting algorithms. So once we understand that, once we understand that as humans, we're much more, we have the ability to think outside what we know, to understand what we're doing, to think like a 10,000 feet level view kind of thing. So if you want to keep your job, or if you want to understand whether your jobs are there, let's answer these questions. Does your job require thinking? Or is it a rote and repetitive job? Well, if your job requires thinking, you're good. AI will not be replacing you because AIs can't think. Otherwise, if your job doesn't require thinking, if a tool took away the repetitive and boring parts, would you start thinking? So maybe you're not thinking not because you're not a thinker, but because 90%, 95% of the time you're doing boring, repetitive stuff. So if an AI took away that thing, because AIs are really good at repetitive and boring stuff, would you be thinking? And if you are going to start thinking, then you're good. AI will be that tool that takes away the repetitive and boring parts. It will be helping you think, and no, you won't be out of a job. Otherwise, if somebody took away that repetitive and boring thoughts and you don't know what to do, can you start thinking? Can you start understanding that, okay, boring and repetitive is out. Now let's start thinking about what to test, how to test it, really strange kind of tests, how people are using the product, UX, and all those really interesting stuff. AI can't even begin to think about. Once you can start thinking, you're good. AI will not be replacing you. It will be helping you as a tool. If you can't start thinking, if you can't really understand, and you're good really only at the boring repetitive jobs, yep, I'm sorry, AI will be replacing you. Not immediately, maybe in 5 years, maybe in 10 years, but AI will be doing that because it will take away the boring and repetitive parts. So if there's one thing you need to take away from this talk, AI is a tool. Use it, benefit from it. Don't worry about it. Just use it, benefit, don't worry. And finally, don't panic. AI is a tool. It's not going to take away your job. So thank you very much.
Questions? Is this the time for questions, Gill?
Yep, I'm available for questions.
Okay, great. So we've got some. First up, how can I incorporate AI into my tests?
Well, machine learning and all those AI algorithms are tough. I mean, we have a team of AI people. They're either masters of science or doctors of science. You need a lot of understanding to really get good algorithms. You can definitely play with AI today. Tensorflow is a really good. All the major companies, Microsoft, Facebook, and Google, have stuff that play. But to really get AI algorithms working, you need a lot of experience with AI algorithms and machine learning. So playing around with it is fine. Um, Using it and really using it in tests, there is a way, but it's definitely not by writing machine learning algorithms or writing whatever. It's using tools that already incorporate AI techniques. And we have those kinds of tools, and they're probably going to get better and better and more of them. Things like applet tools, visual testing, things like testim.io, which does record and replay and enables you to write your tests in an easier way, and other Mabel and other kinds of companies, they incorporate those AI algorithms. They have those teams of AI people that write the machine learning and deep learning and algorithms and incorporate them into the testing tools. Use those testing tools, use the AI in them. Don't worry about writing machine learning stuff. Now, if I may, there are places where you need to write machine learning stuff. I've seen a talk about the Candy Crush. King is the company. They have Candy Crush, the Candy Crush product. And testing Candy Crush, if you think about it, is non-trivial. So they're using machine learning algorithms to try and test all those really weird levels and figure out whether they're good levels or impossible levels or too easy levels, and figure that out. These kinds of things. Yeah, maybe. But remember, if you want to go into machine learning, we're talking like a year of experience before you get significant results from those. Any else?
Yeah, so we got a lot of really great questions, but I want to take the next moment just to share with you. This is our last event of the year, but our friends at ThisDot are having a roundtable with a star-studded roundtable. Actually, Gill is going to be there with Kevin Lamping and Jim Evans and Kenzie Dodds. Oh, so this is happening next week on December 18th, and I just put a link in the chat room for the registration page and for more info. Oh, so that will be like a roundtable debate about different kinds of tests, tools used, how testing is different, how is testing done on different frameworks and best practices. So worthwhile checking that out. So again, the link is there. Feel free to click and check that out. And our next question. Any latest test automation tools using machine learning now? Do we have any test automation tools that are using machine learning and AI at the moment?
Yes, applet tools, obviously, using lots of visual AI algorithms to compare those screenshots, both compare an exact comparison, what we call strict, and layout algorithms where we check that the layout is the same even if the data is different. So applet tools is one tool. Testim and Mabel, and I believe other companies use, these are where you can write your tests by recording what you do. So the idea is in their AI techniques are to make those tests resilient to future changes in the page. So even if the page changes, those AI algorithms will understand that the page changed and adapt the test so that it won't, fail because the selector was wrong. Those are the two kinds of AI tooling I've seen in companies. I'd love to see what's coming, in the next 5 years.
I guess the follow-up question or questions we're actually getting here. So are there any AI tools available in market for using in testing and specifically in test automation? And do you know of any AI or machine learning based software testing libraries that can be used now?
Right. No, I've never seen, and I've been studying and researching this topic for about a year. I've never seen something that is specific to software testing. Uh, I have seen a lot of, tools. The most famous one is TensorFlow, and TensorFlow JS for JavaScript, and TensorFlow for, I think it's Python, where you can create machine learning models using really simple stuff. Azure has tools for doing that. It's really, really nice. You can, input all the pictures and take out whether, it's Arnold Schwarzenegger or something. Uh, Tools that are specific to testing, I've not seen. No, not yet. Who knows? Maybe one of you will write it.
Um, do you think that the actual definition of AI is getting conflated with machine learning and deep learning, and that in fact we're not really discussing AI at all?
Yes. And what would the algorithms that we're using are machine learning, deep learning, and other algorithms. It's not only those. Those are the most famous, but it's others. Whether it's AI or not, in the 60s there was this big AI revolution, which turned out, to fail miserably at everything it tried. And then I think in the 80s again, or the 90s, I'm not sure. Uh, this is the first AI revolution that is succeeding in really doing stuff. So yeah, I mean, is it really, artificial intelligence where intelligence is like human intelligence? No. But is it doing stuff that is real and useful? Definitely. So, AI or not AI, it's just terminology. Useful? Definitely.
When you say that algorithms are easily fooled, do you believe that this is an inherent and ongoing truth of machine and deep learning, or just an issue due to the current level of complexity of existing neural networks?
From what I understand, and I'm not an expert here, it's inherent, and what the AI people are doing to fix that is not, doing other kinds of algorithms that have more understanding, but just fine tuning their algorithms to avoid these kinds of flaws. So they're staying in the not understanding level of AI, as in machine learning and deep learning, and just fine tuning and making it better and better so that it will um, ignore these flaws. It's still not understanding. It knows that it's the banana, but it doesn't really know what a banana is. So if it sees a gorilla next to it, it won't know the connection. Whilst we look at the banana, look at the gorilla, and make that connection immediately. So yeah, they'll probably get better at ignoring these kinds of flaws, but it's still not real understanding.
We're getting a lot of questions about how to learn more about this topic. So I'm just going to take the first one, or the most comprehensive one. How and where can I learn more about machine learning and other AI techniques, specifically with regards to software testing?
Specifically with regards to software testing is difficult. As I said, there's not a lot out there. There's the talk given by Candy Crush people, the King company. There's a really nice talk. I really liked it, by Angie Jones, about the talk is interesting because it's not using machine learning techniques, but it's actually um, testing an algorithm that was used by Twitter in this example, and figuring out whether the algorithm is doing good prediction or not. I love the talk. It's part of Agile Testing Days. I'm pretty sure you can find it online. But learning about software testing tools that use AI, there are not a lot of companies that do it. It's still not, commonly used. I would say again, I mean, going the path of writing those machine learning algorithms and AI algorithms is like take 1 year off, 2 years off, and start, working with that using tools like TensorFlow, and figuring out what you want, etc. Or alternatively, use the tools like Mabel and Testim and Apple tools to help you there.
And we're getting questions also not just in regards to software testing, but in general, your preferred resources to learn about AI and machine learning.
When I started this, I wanted to play with AI, so I went to TensorFlow. TensorFlow is that's why I keep, I'm not an AI person. I keep getting back to it because that is how I researched the subject and learned about AI and played around with it. It's a really cool tool.
So, do you think AI-powered testing is an overkill for testing web and mobile apps, which traditionally have used Selenium-based testing?
I wish it was overkill. I mean, I wish I could, just give the AI the app and have it test it. We're not there. We're totally not there. Um, we're talking about visual comparisons. We're talking about better selectors, less flaky tests, more resilient tests according to changes. Uh, I mean, those are companions to tests you write. In the case of amplitudes, they're not companions. You're still writing those tests, but the validations are driven by AI. And I don't think they're over. I wish they were overkill, but currently they're underkill in that they can't do everything. So, yep.
How do you see the AI testing applied on the system integration level that is not UI?
I've never seen a tool that does that. Theoretically, one can, build machine learning AI that, throws a REST API call to a backend and gets back a response and, figures out from the parameters that were sent and from the response that were gotten whether it is the correct response. But as I said, I don't really believe we're there yet. But who knows? Who knows? Maybe a tool will come out that does that. I haven't seen them.
Do you think we're looking at a future that we have AI testers in it? And if you do, where would one start in order to manage his career path to go there?
Oh, career path in AI testing. Come back in 5 years and we'll probably be talking about it. Maybe. Currently, if you want to prepare, start doing machine learning stuff. Start playing around with it. Unfortunately, in your own spare time, because it's not yet useful unless you use tools like amplitudes or testing or others. Start doing machine learning. Take TensorFlow, play around with it. Take the Azure AI stuff or the Amazon AI stuff. It's free. It's fun. You throw images at it. There are so many image banks today that support AI. You can just play around with it, learn, improve your ability to do machine learning. Is it a career path today? I don't know. I don't think so. Maybe in 5 years it will start to become that, but I don't think we're there yet.
Okay, so from what I see now, these are all the questions that we have. So I want to thank all of you for joining us for this end of year session, and of course I want to thank Gill for this presentation. I just want to remind you that the link to the recording of this session will be emailed to you by Friday, and I hope to see you in our 2019 events. So thank you, and again, check out this event next week about the roundtable regarding software testing.